Semiconductors form the invisible architecture of contemporary technology, enabling the seamless operation of devices that define daily life and drive global industries. Among the diverse players in this ecosystem, Nexperia stands out as a specialist in discrete semiconductors, components such as diodes, transistors, and power management devices that serve as the foundational elements for the most integrated systems. Established in the Netherlands, with a legacy tracing back to Philips' pioneering work in the mid 20th century, Nexperia has evolved into a global leader under Chinese ownership since 2019, when Wingtech Technology acquired it to form NXP Semiconductors. This essay examines Nexperia from an engineering standpoint, delving into its core technologies, manufacturing processes, and innovative applications. It further explores the company's strategic significance in the broader semiconductor landscape, particularly amid escalating geopolitical pressures exemplified by the recent Dutch government intervention in 2025. By analyzing these dimensions, the discussion reveals how Nexperia's engineering excellence not only sustains critical supply chains but also underscores the vulnerabilities inherent in the international technology dependencies. Nexperia's story is deeply rooted in European engineering tradition. The company's origins lie in the Philips Research Laboratories, where in 1953, engineers in Eindhoven developed one of the world's first silicon transistors, marking a pivotal shift from vacuum tubes to solid state electronics. The innovation laid the groundwork for discrete components that could handle amplification and switching with unprecedented reliability. Over the decades, Philips expanded its semiconductor operations, establishing a major facility that became synonymous with high volume production of bipolar transistors and rectifier diodes. By the 1980s, this site was producing millions of units on a daily basis, supporting the boom in consumer electronics like televisions and early personal computers. The transition to Nexperia occurred in 2016 when NXP, itself a Philips spin off, sold its standard products division to a consortium led by China's Wise Road Capital for 2.25 billion euros. Renamed Nexperia in 2017, the company retained its Dutch headquarters and European research and development hubs while scaling operations in Asia. The acquisition injected capital for expansion, but it also introduced complexities related to intellectual property and supply chain localization. Engineering wise, Nexperia's heritage manifests in its unwavering focus on discrete devices, which differ from integrated circuits by performing singular functions with extreme precision. These components must endure harsh environments, temperatures from minus 55 degrees Celsius to 175 degrees Celsius in automotive applications, for instance, demanding rigorous material science and process controls. Today, Nexperia operates 8 manufacturing sites worldwide, including front end wafer fabrication in Hamburg, Germany, and an assembly test facilities in the Philippines, Malaysia, and China. Its engineering teams, comprising over 1,000 specialists, prioritize yield optimization and cost reduction through proprietary tools developed by Subsidy Integrated Technology Express, or the ITEC. This historical continuity ensures that Nexperia's products inherit decades of refined know how, such as the planar diffusion process for diodes that achieve breakdown voltages exceeding 1000 volts with minimal leakage currents below 1 nanoampere. At the technical core, Nexperia's portfolio revolves around discrete and power semiconductors, engineered for efficiency in power conversion, signal integrity, and protection. Discrete diodes, for example, form the backbone of rectification circuits and power supplies. These devices leverage advanced epitaxy technologies, growing thin silicon layers via chemical vapor deposition to control doping profiles precisely, ensuring high surge current ratings up to 150 amperes. Transistors represent another pillar, where Nexperia's bipolar junction transistors, or BJTs, and MOSFETs excel in switching applications. The company's Next Power family of MOSFETs employs super junction architecture, interleaving N and P columns in the drift region to balance on resistance and breakdown voltage. For a 100-volt device, this yields an balance on resistance of just 2.5 milliohm, coupled with a gate charge of 15 nanocoulomb, resulting in a figure of merit that outperforms competitors by 20 to 30%. Packaging innovations such as copper clipped LF pack or loss-free packaging enhance thermal dissipation up to 3 watt per degree Celsius, junction to ambient, allowing denser board layouts in space-constrained designs like electric toothbrushes or wearable fitness trackers. Silicon carbide Schottky diodes in the 1200 volt class, built on 4H silicon carbide substrates with hexagonal crystal lattices, deliver blocking voltages with 10x lower leakage than silicon PN diodes, ideal for high-frequency inverters in photovoltaic systems. Engineering these involves ion implantation for precise edge termination structures, reducing field crowding and enabling 600 volts to 20 ampere ratings in TO247 packages. Similarly, gallium nitride high electron mobility transistors or HEMTs exploit the two-dimensional electron gas at the interface, achieving electron mobilities over 2000 centimeters square per volt second. Nexperia's 100-volt enhancement mode gallium nitride FETs switch at 100 MHz with less than 1 nanosecond rise times, slashing switches between 70% in the Class D audio amplifiers and fast charging adapters. Beyond components, Nexperia integrates discrete elements into application-specific solutions. The acquisition of Novi in 2023 bolstered its energy harvesting portfolio. The BQ25570 based ICs now incorporate Nexperia's ultra-low power diodes to harvest ambient RF energy, powering wireless sensors with conversion efficiencies exceeding more than 90% from inputs as low as 100 millivolts. ESD protection devices round out the lineup. The bidirectional TVS arrays rated for 30 kV contact discharge per IEC. These innovations are validated through extensive simulations using tools like Silvaco TCAD for device physics modeling and real-world testing in labs simulating automotive EMC environments. Nexperia's annual output surpasses 100 billion units, supported by automated lines achieving 99.5% yields. The scale stems from lean engineering practices, including statistical process control and machine learning for defect prediction, ensuring consistency across global fabs. Nexperia's technology permeates diverse sectors, demonstrating their versatility. In automotive electronics, which accounts for more than 40% of the revenue, MOSFETs and IGBTs, or insulated gate bipolar transistors, drive the powertrains, and a typical EV inverter uses Nexperia's 650 volt silicon carbide modules to convert DC battery power to 400 volt alternative current, achieving 98% efficiency and reducing cooling needs by 50%. This supports compliance with ISO 26262 functional safety standards, where failure rates below 10 failures in times are mandatory. Industrial automation benefits from robust discretes in motor controls and programmable logic controllers. Nexperia's intelligent power switches, like the Novolith IC family, combine MOSFETs with integrated drivers and diagnostics, enabling predictive maintenance in smart factories by monitoring die temperatures via embedded sensors. In renewables, diodes and thyristors optimize grid-tied inverters where the high voltage gradient prevents false triggerings during voltage transients. Consumer and mobile markets leverage compact ESDs and logic solutions. For 5G smartphones, Nexperia's multi-line protectors safeguard the millimeter wave module's 8 kV air discharges, while low RDS MOSFETs in battery management systems extend runtime by optimizing charge-discharge cycles. Emerging IoT applications such as smart home hubs integrate Nexperia's eFuses for overcurrent protection, resetting automatically after faults to enhance reliability in always-on devices. Nexperia's engineering strengths confer profound strategic value, positioning it as a cornerstone of the $600 billion semiconductor industry. Discrete and power devices, through comprising of 15% of the market, enable 80% of electronic systems by handling energy flow and interfacing with the physical world. With a 10% share in discretes, Nexperia supplies indispensable components to OEMs like Apple, Samsung, and Volkswagen, generating 2 billion euros in the 2024 revenue. Geopolitically, its role amplifies amid supply chain fragilities. The 2021 chip shortage exposed reliance on Asian assembly. Nexperia's Guangdong facility processes 70% of global output, making it a potential single point of failure. This mirrors broader trends. The EU Chip Act aims for 20% self-sufficiency by 2030, yet mature node discretes lag behind advanced logic. Nexperia's European fabs in Hamburg and Netherlands anchor this effort, preserving IP and skill transfer. Ownership dynamics add layers. Wingtech's stake ties Nexperia's to China's Made in China 2025 initiative, fostering technology localization while raising Western concerns over dual use risks. Discrete components underpin military radars and missile guidance, prompting scrutiny under frameworks like the Wassenaar Agreement. The 2025 Dutch intervention seizing governance to prevent IP migration highlighted these tensions, disrupting exports and costing the auto sector almost 5 billion euros in delays before partial resumption. Comparatively, rivals like Infineon, which are strong in automotive silicon carbide semiconductors, and on semiconductor emphasize integration, but Nexperia's pure play discrete focus yields cost advantages and devices at very low costs, which democratizes access for small and medium enterprises. This sustains innovation cycles, funding R&D into next generation materials like diamond semiconductors for more than 10 times the thermal conductivity. Engineering at Nexperia navigates formidable challenges. Supply chain volatility demands dual sourcing. Post 2025, plans for a new Indian fab aim to diversify from China. Sustainability pressures mount as fab consumes 10% of global electricity, prompting Nexperia's shift from traditional manufacturing methods. Cybersecurity threats, as in 2024 ransomware incident, requires the company to improve its zero trust architectures to protect design files. The geopolitical arena poses existential risks. The Dutch action, rooted in the Goods Availability Act, reflected US entity list pressures, echoing the UK's 2022 Newport divestiture. China's countermeasures, export halts, weaponized discretes, revealing how commodity tech sustains advanced systems, and resolutions via arbitrations underscore the need for multilateral dialogues, perhaps through the World Trade Organization mechanisms. Looking ahead, Nexperia eyes growth in electrification and AI. By 2030, EV penetration could double demand for power discretes. Semiconductors scaling via 200mm wafers promises 40% cost drops. These improvements will be crucial for the coming days. Acquisitions like Novi Signal expansion into the analog mixed signal, while US R&D hubs counter decoupling. Engineers will drive this via quantum simulations for defect engineering and AI-optimized solutions. Nexperia embodies the enduring power of focused engineering in discrete semiconductors, transforming raw silicon into reliable enablers of progress. Its innovations in materials, processes, and applications not only power industries but also highlight the strategic imperatives of a resilience and collaboration. As geopolitical storms rage, protecting such assets demand nuanced policies that harness global expertise without fracturing the chains. In this balance lies the path to a technologically sovereign future, where Nexperia's quiet contributions continue to illuminate the world.